battery may pay for itself. 72. In 2010, the Nissan Leaf battery pack was reportedly produced at a cost of $18,000. 73. Nissan's initial production costs at the launch of the Leaf were therefore about $750 per kilowatt-hour for the 24K battery. 73. In 2012, McKinsey quarterly linked battery prices to gasoline prices on a basis of 5-year total cost of ownership for a car, estimating that $3.50/gallon equates to $2.50/kilowatt-hour. 74. In 2017, McKinsey estimated that electric cars will be competitive at a battery pack cost of $100/kilowatt-hour, expected around 2030, and expects pack costs to be $190/kilowatt-hour by 2020. 75. In October 2015, car maker GM revealed at their annual global business conference that they expected a price of $145 per kilowatt-hour for Li-ion cells entering 2016. 54. Range parity. Driving range parity means that the electric vehicle has the same range as an average all-combustion vehicle, 500 kilometers or 310 miles, with batteries of specific energy greater than 1 kilowatt-hour/kilogram. 76. High range means that the electric vehicles would run more kilometers without recharge. Currently, electric vehicle sales are lower than expected due to range anxiety, even with the same range as an average all-combustion vehicle. Buyers must be assured that there are widely available and compatible charging stations for their vehicles, which are currently not as common as gas stations. 77. Japanese and European Union officials are in talks to jointly develop advanced rechargeable batteries for electric cars to help nations reduce greenhouse gas emissions. Developing a battery that can power an electric vehicle 500 kilometers, 310 mi, on a single charging is feasible, said Japanese battery maker GS Yuasa Corporation. Sharp Corp and GS Yuasa are among Japanese solar power cell and battery makers that may benefit from cooperation. 78. The lithium-ion battery in the AC propulsion SRO provides 400 to 500 kilometers, 200 to 300 mi, of range for charge, single charge range. 79. The list price of this vehicle when it was released in 2003 was $220,000. 80. Driving in a Daihatsu Miura equipped with 74 kilowatt-hour lithium-ion batteries. The Japan EV Club has achieved a world record for an electric car, 1,003 kilometers, 623 mi, without recharging. Zonda Bus, in Jiangsu, China offers the Zonda Bus New Energy with a 500 km, 310 mi, only electric range. 81. The supercar Rimac Concept 1 with 82 kWh battery has a range of 500 km. The car has been in production since 2013. The pure electric car BYD E6 with 60 kWh battery has a range of 300 km. 82. Specifics. Internal components. Battery pack on the roof of a battery electric bus electric truck E-Force 1. Battery pack between the axles. Battery pack designs for electric vehicles, EVs, are complex and vary widely by manufacturer and specific application. However, they all incorporate a combination of several simple mechanical and electrical component systems which perform the basic required functions of the pack. The actual battery cells can have different chemistry, physical shapes, and sizes as preferred by various pack manufacturers. Battery packs will always incorporate many discrete cells connected in series and parallel to achieve the total voltage and current requirements of the pack. Battery packs for all electric drive EVs can contain several hundred individual cells. Each cell has a nominal voltage of 3 to 4 volts, depending on its chemical composition. To assist in manufacturing and assembly, the large stack of cells is typically grouped into smaller stacks called modules. Several of these modules are placed into a single pack. Within each module, cells are welded together to complete the electrical path for current flow. Modules can also incorporate cooling mechanisms, temperature monitors, and other devices. Modules must remain within a specific temperature range for optimal performance. 83. In most cases, modules also allow for monitoring the voltage produced by each battery cell in the stack by using a battery management system, BMS. 84. The battery cell stack has a main fuse which limits the current of the pack under a short circuit. A service plug or service disconnect can be removed to split the battery stack into two electrically isolated halves. With the service plug removed, the exposed main terminals of the battery present no high potential electrical danger to service technicians. 84. 85. The battery pack also contains relays, or contactors, which control the distribution of the battery pack's electrical power to the output terminals. In most cases there will be a minimum of two main relays which connect the battery cell stack to the main positive and negative output terminals of the pack, which then supply high current to the electrical drive motor. Some pack designs include alternate current paths for pre-charging the drive system through a pre-charge resistor or for powering an auxiliary bus, which will also have their own associated control relays. For safety reasons these relays are all normally open. 84. 85. The battery pack also contains a variety of temperature, voltage, and current sensors. Collection of data from the pack sensors and activation of the pack relays are accomplished by the pack's battery monitoring unit, BMU, or BMS. The BMS is also responsible for communications with the vehicle outside the battery pack. 84. Recharging. Batteries in BEVs must be periodically recharged. BEVs most commonly charge from the power grid, of them or using a street or shop recharging point, which is in turn generated from a variety of domestic sources, such as coal, hydroelectricity, nuclear, natural gas, and others. Home or grid power, such as photovoltaic solar cell panels, wind, or microhydro may also be used and are promoted because of concerns regarding global warming. With suitable power supplies, good battery lifespan is usually achieved at charging rates not exceeding half of the capacity of the battery per hour, 0.5 C, 86, thereby taking 2 or more hours for a full charge, but faster charging is available even for large capacity batteries. 87. Charging time at home is limited by the capacity of the household electrical outlet, unless specialized electrical wiring work is done. In the US, Canada, Japan, and other countries with 120 V electricity, a normal household outlet delivers 1.5 kilowatts. In other countries with 230 V electricity, between 7 and 14 kilowatts can be delivered, 230 V single-phase and 400 V three-phase, respectively. In Europe, a 400 V, three-phase 230 V, grid connection is increasingly popular since newer houses don't have natural gas connection due to the European Union's safety regulations. Recharging time. Electric cars like Tesla Model S, Renault Zoe, BMW i3, etc., can recharge their batteries to 80% at quick charging stations within 30 minutes. 88, 89, 90, 91. For example, a Tesla Model 3 long-range charging on a 250 kilowatts Tesla version 3 supercharger went from 2% state of charge with 6 miles, 9.7 kilometers, off range to 80% state of charge with 240 miles, 390 kilometers, of range in 27 minutes, which equates to 520 miles, 840 kilometers, per hour. 92. Connectors. The charging power can be connected to the car in two ways. The first is a direct electrical connection known as conductive coupling. This might be as simple as a mains lead into a weatherproof socket through special high-capacity cables with connectors to protect the user from high voltages. The modern standard for plug-in vehicle charging is the SAE 1772 conductive connector, IEC 62196 Type 1, in the US. The ACEA has chosen the VDERE 2623-2-2, IEC 62196 Type 2, for deployment in Europe, which without a latch, means unnecessary extra power requirements for the locking mechanism. The second approach is known as inductive charging. A special paddle is inserted into a slot on the car. The paddle is one winding of a transformer, while the other is built into the car. When the paddle is inserted, it completes a magnetic circuit which provides power to the battery pack. In one inductive charging system, 93, one winding is attached to the underside of the car, and the other stays on the floor of the garage. The advantage of the inductive approach is that there is no possibility of electrocution as there are no exposed conductors, although interlocks, special connectors and ground fault detectors can make conductive coupling nearly as safe. Inductive charging can also reduce vehicle weight by moving recharging componentry off-board. 94. An inductive charging advocate from Toyota contended in 1998 that cost differences were minimal, while a conductive charging advocate from Ford contended that conductive charging was more cost-efficient. 94. Recharging spots. As of April 2020, there are 93,439 locations and 178,381 EV charging stations worldwide. 95. Though there are a lot of charging stations worldwide, and the number is only growing, an issue with this is that an EV driver may find themselves at a remote charging station with another vehicle plugged into the only charger, or they may find another vehicle parked in the only EV spot. Currently, no laws prohibit unplugging another person's vehicle, it is simply ruled by etiquette. 77. Travel range before recharging. The range of a BEV depends on the number and type of batteries used. The weight and type of vehicle as well as terrain, weather, and the performance of the driver also have an impact, just as they do on the mileage of traditional vehicles. Electric vehicle conversion performance depends on a number of factors including the battery chemistry. Lead-acid batteries are the most available and inexpensive. Such conversions generally have a range of 30-80 kilometers, 1950 mi. Production EVs with lead-acid batteries are capable of up to 130 kilometers, 81 mi, per charge. NiMH batteries have higher specific energy than lead-acid. Prototype EVs deliver up to 200 km, 120 mi, of range. New lithium-ion battery-equipped EVs provide 320-480 km, 200-300 mi, of range per charge. 96. Lithium is also less expensive than nickel. 97. Nickel-zinc batteries are cheaper and lighter than nickel-cadmium batteries. They are also cheaper than, but not as light as, lithium-ion batteries. 98. The internal resistance of some batteries may be significantly increased at low temperature. 99. Which can cause noticeable reduction in the range of the vehicle and on the lifetime of the battery. Finding the economic balance of range versus performance, battery capacity versus weight, and battery type versus cost challenges every EV manufacturer. With an AC system or advanced DC system, regenerative braking can extend range by up to 50% under extreme traffic conditions without complete stopping. Otherwise, the range is extended by about 10 to 15% in city driving, and only negligibly in highway driving, depending upon terrain. BEVs, including buses and trucks, can also use genset trailers and pusher trailers in order to extend the range when desired without the additional weight during normal short-range use. Discharged basket trailers can be replaced